Before NASA built the Lunar Rover, it almost built something else. It had no wheels, it didn't drive, it wasn't even supposed to touch the ground most of the time. For a while, NASA seriously considered flying astronauts across the moon. So, why did NASA abandon the idea? Let's start with the reason behind any lunar vehicle. When Apollo 11 landed, Neil Armstrong and Buzz Aldrin barely went anywhere. Their entire moonwalk stayed within about 200 feet. Not because there was nothing interesting farther away, but because walking on the moon was slow, exhausting, and the farther they went, the greater the risk became. A damaged suit, a fall, an oxygen problem, too far from the lander, and getting home might no longer be possible. NASA understood this limitation years before the first moon landing, so engineers began asking a simple question. What if astronauts didn't have to walk at all? What if they could fly? NASA's interest in a lunar flying vehicle wasn't just a vague idea. By the mid-1960s, NASA was formally studying a concept known as the Lunar Flying Unit, the LFU. The goal was simple: give astronauts a way to travel much farther from the lunar module than walking would ever allow. And because the moon has virtually no atmosphere, flying could only be done with rocket propulsion. As the Apollo program progressed, NASA turned the idea into a real engineering effort. Rather than committing to a single design, the agency explored several different concepts, from backpack propulsion systems to standing and seated flying platforms. In 1969, Bell Aerosystems and North American Rockwell were each tasked with developing their own concept for a lunar flying vehicle. Bell based its concept on the Bell rocket belt, later expanding it into a larger flying platform known as the Bell Pogo. North American Rockwell, already developing the Apollo Command and Service Module, proposed its own flying platform and carried out tests using lunar surface simulators. On paper, the moon actually helped. Its gravity is only 1/6 of Earth's. A propulsion system that would struggle to lift a person on Earth suddenly became much more practical. Generating enough thrust no longer looked impossible. Controlling it was the real challenge. Some concepts had astronauts standing upright, which sounds simple, until you remember they'd be wearing a stiff, pressurized spacesuit, limited visibility, restricted movement. So engineers also explored seated designs, hoping a lower center of gravity would improve stability. The propulsion looked feasible, but keeping a person balanced, level, and fully in control while hovering over an alien landscape, that was the real challenge. And there was another unavoidable limitation: fuel. Unlike a rover, every second spent flying consumed part of the vehicle's total range. Every movement of the controls shortened the trip home just a little more. Now imagine yourself several miles from the lunar module. You're not driving, you're flying. If the rover failed, the vehicle would simply stop. You'd have a very bad day, but you'd still be standing on the ground. A flying vehicle was different. Its biggest advantage was that it could fly over obstacles instead of driving around them. But that advantage came at a price. A propulsion failure during flight could mean losing control and crashing back onto the surface. Even with 1/6 gravity, it was still a crash. And there was another problem: payload. Most flying concepts could carry little more than the astronaut. Scientific instruments, rock samples, extra equipment, all of it added weight. Every extra pound required more propellant. A flying platform could move a person quickly, but Apollo missions weren't just about moving people. They were about bringing science back home. By May 1969, even before the studies had concluded, NASA had already decided to move in a different direction. Instead of developing a flying vehicle, the agency shifted its focus to a lunar rover. NASA wasn't rejecting rocket propulsion itself. Apollo astronauts would soon land on the moon using a rocket engine, and leave it the same way. The problem wasn't the rockets. It was asking astronauts to manually fly one, just a few feet above an unforgiving lunar surface. Following the success of Apollo 11, The rover program moved quickly. In October 1969, Boeing was selected to build the Lunar Roving Vehicle, a machine that could carry 2 astronauts, their equipment, and hundreds of pounds of lunar samples, all while offering a far larger safety margin. So here's the real question. NASA chose the rover. History suggests that was almost certainly the right decision. But imagine the alternative. Astronauts flying over lunar craters, testing personal rocket vehicles on another world. Would it have been a reckless gamble with far more risk than reward? Or could those missions have accelerated personal spaceflight technology? Would you have taken that risk?